We're on lesson 4 of chapter 10, which is theoretical probability. First, we're going to find theoretical probability, then we'll solve a real-world problem. Let's say you're out one night running the bingo game, and there are 75 bingo balls total, and 15 have the letter B, and you ask yourself, what are the odds that the next ball will have a B? Well, we could do what we did in a previous lesson where we did experimental probability, by randomly selecting a certain amount of bingo balls and then recording our results, and then using those results to predict the next one. Or we could do theoretical probability, which is what we're doing today. We could calculate the probability by examining possible outcomes. For example, if I do know that there are 75 bingo balls and 15 have the letter B, I can use this theoretical probability equation to solve. The probability is equal to the number of ways the event can occur. Let's say I wanted to have B, that'd be 15 ways it could occur, over the total number of equally likely outcomes. And since all these balls have the same shape, they are equally likely outcomes of 75. So my theoretical probability for this one would be 15 letter B balls over 75 total bingo balls. Simplifying that would turn into 1/5. So let's try that in a few of these. It says find the probability of each event, write your answer as a fraction, as a decimal, and as a percent. So our first one is selecting one of the 4 queens from a deck of 52 cards. Remember, our equation is the probability of that would be the number of ways that an event can occur over the total number of equally likely outcomes. Well, there's 52 total cards to choose from, and they're all just as likely to be picked as the other ones. So equally likely outcomes on the bottom is 52, and then any of those 4 queens would make this event occur. So it'd be 4 over 52. Simplifying that, dividing each by 4 would give us an answer of 1/13. Finding the decimal by doing 1 divided by 13 would give me an answer of 0.0769 or 0.77. Moving that decimal over twice to give me a percent would be 7.7%. Let's try for this one then. It says rolling a number greater than 2 on a fair numbered cube. So the total number of likely outcomes would be 6, and they're all equally likely because the cube is fair. Then the numbers that are greater than 2, that would be 3, 4, 5, or 6, meaning that there's 4 total possibilities. So if I simplify 4 over 6, that gives me the odds of 2/3. Dividing this to turn it into a decimal would give me 0.666 ongoing, so 0.67 if we round it. And then moving that decimal over to get a percent would be 67%. Now we can solve this problem. There are 11 boys and 16 girls in Mr. Ashley's class. Mr. Ashley has written the name of each student on a craft stick. He randomly chooses one of these sticks to choose a student to answer a question. It says find the theoretical probability of choosing a boy's name. So since they're all on a craft stick, that makes them all equally likely. And he could choose either the boys or the girls. So we have to add that together to find the total amount of outcomes. So 16 plus 11 is 27. So there's a total of 27 craft sticks with names on them. And we're looking for the event of choosing a boy's name. So there's 11 total ways that could occur. So this is the theoretical probability of choosing a boy's name, 11 over 27. Now we need to find the theoretical probability of choosing a girl's name. Total number of outcomes remains the same. There's 27 sticks with boys and girls, but the event we're looking for this time would be 16. You could tell that these ones are complements because 11 over 27 plus 16 over 27 would equal 27 over 27, which is 100%, meaning that it's a 100% chance that he's going to pick a boy or a girl when he picks those sticks.